Hello, today we're going to look at solving quadratics using the quadratic formula. And the great thing about the quadratic formula is it doesn't involve factoring. So this works completely separate from factoring. And we're going to look at first in our first video at leaving our answers as radicals. So what is the quadratic formula and what is it used for? Well, the quadratic formula is used to solve quadratic equations. And what is the quadratic formula? It is x equals negative b plus or minus the square root of b squared minus 4ac over 2a. And to use the quadratic formula, the equation must be in descending order equal to 0, also known as standard form. And all quadratic equations can be written in this form where a, b, and c are constants and a cannot be 0. So this disclaimer that says a can't be 0, that has to do with if I multiplied 0 times x squared, my x squared term would go away, and then I would no longer have a quadratic. So to use the quadratic formula, I have to have a quadratic. I have to have an exponent of 2, or I don't have a quadratic to use the quadratic formula with. So you have to have a squared term. Now you can have 0 for b value or c value, but the a value can't be 0 because multiplying by 0 would make the quadratic part go away. So here are some examples of quadratics. We see an exponent of 2, and then we see some descending order exponents, degree of 1, some constants. Notice how in this one, this last one here, there's no c value. That's not a mistake. There's just the c value would be 0 if there's no constant. But do notice that all the quadratics, they all have a squared term. This one has 2x squared, negative 5x squared, x squared. We have to have a squared term in order to use quadratic formula. And the quadratic formula again, x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. And we can look at the quadratic equation below and compare it to standard form. So if I have x squared plus 5x plus 6 equals 0, and if I'm looking for the a term, the b term, and the c term. Well, if I'm making some comparisons, we're looking for the number in front of the x term. Well, there's only an x term, so 1 would be the a value. If I'm looking for the number in front of the b, well, I have a 5 for the b value, and they're both plus, so they're both positive. And I have a 6 for the c value. So by comparing my quadratic equation to standard form, I can now identify the a value, b value, and c value. So if I have an a of 1, a b of 5, and a c of 6. So identifying this a value, b value, and c value, these are the numbers that I can substitute into the quadratic formula to solve my quadratics. So what does that look like? Well, everywhere I see a, I'm going to substitute in a 1. Everywhere I see a b, I'm going to substitute in a 5. And everywhere I see a c, I'm going to substitute in a 6. So I'm just going to take this negative b plus or minus the square root of b squared minus 4ac over 2a and substitute in my a value, my b value, and my c value. And when I substitute in, I get negative 5 plus or minus the square root of 5 squared minus 4 times 1 times 6 over 2 times 1. Now I can look at doing some reducing. Before I start reducing or doing any type of operations, I really want one clean substitution. Try not to do any operations, just get in a substitution straight from the a, b, and c value into the quadratic formula. Otherwise, you have much more likelihood of having some errors. So to avoid errors, try to get in one clean substitution. So then I can start working this out a little bit. 5 squared is 25, 4 times 1 times 6 is 24 minus 24, 2 times 1 is 2. So I can start working this out a little bit. Then 25 minus 24 is 1. Then I have negative 5 plus or minus the square root of 1 over 2. Square root of 1, well, 1's a perfect square. 1 times 1 is 1. So I could have negative 5 plus or minus 1 over 2. And this plus or minus sign, this is where we end up getting our two solutions like we saw happen very often when we were doing factoring, is I can do negative 5 minus 1 Oh, I did plus first. Negative 5 plus 1 is negative 4 over 2 is negative 2. And then I could do negative 5 minus 1. Negative 5 minus 1 is negative 6 divided by 2 is negative 3. So my two solutions are negative 2 and negative 3. And when I have a set of solutions, it's common to have set notation where I put this inside of brackets, braces. So your turn. You guys pause the video here, identify the A, B, and C value, and put that into the quadratic formula and solve. All right, welcome back. We should have identified an A of 1, a B of negative 2, and a C of negative 48. Substitute those into the quadratic formula. I have this negative 2, where the opposite of negative 2 is positive 2. Negative 2 squared is 4. And I have a negative times a positive times a negative. So I'm going to get plus, and I can do 4 times 48 in my calculator. 2 times 1 I can do in my head. So I get 4 times 1 times 48 was 192. Plus 4 is 196. And 196 is a perfect square. The square root of 196 is 14. So my two solutions are going to come from 2 plus 14 divided by 2 and 2 minus 14 divided by 2. 2 plus 14 is 16, divided by 2 is 8, and 2 minus 14 is negative 12, divided by 2 is negative 6. So I get 2 plus 14 over 2 is 16, divided by 2 is 8. 2 minus 14 over 2 is negative 12, divided by 2 is negative 6. So my two solutions are 8 and negative 6. 8 and negative 6 are our two solutions. We still have rules for simplifying radicals when we're doing quadratic formulas. So when we have the square root of 32, we are looking to pull out perfect square factors. And 32 has the largest perfect square factor of 32. If I think of my perfect squares between 0 and 100, I come up with 16 would be the largest perfect square that will go into 32. And the square root of 16 is 4. So when I simplify this, I'd have 4 radical 2. If I look at simplifying the square root of 45, the largest perfect square factor of 45 is 9. And the square root of 9 is 3, so I have 3 radical 5. So we're still going to have to simplify radicals when it comes to the quadratic formula, and you're going to be simplifying radicals by pulling out perfect square factors. All right, so let's try. We have the quadratic equation. 0 is equal to 2y squared plus 4y minus 1. So we have an a value of 2, a b value of 4, and a c value of negative 1. We're going to substitute in. Everywhere we see a, we're going to put 2. Everywhere we see b, we'll put 4. And for our c, we'll put negative 1. Once again, try to do that substitution without doing any operations first. Then we can work on simplifying. 4 squared is 16. Negative times a positive times a negative is positive. 4 times 2 is 8 times 1 is 8. 2 times 2 is 4. And I get the square root of 16 plus 8. The square root of 16 plus 8 is 24. Now, 24 is not a perfect square factor, so I'm looking at pulling out the largest perfect square factor possible out of 24 is 4. And the square root of 4 is 2. So I pull the 2 to the outside, and I have 2 radical 6. Now, we have to simplify this, and it's a little different than we're used to seeing because we're looking at 3 places to see if any number will divide evenly into this term, the term in front of the radicand, and the denominator. What number will divide evenly into 2, 4, and 4? Well, the number that can divide into all 3 is 2. They're all divisible by 2. So to reduce this radical, I have to divide each of those by 2 to get negative 2 plus or minus radical 6 over 2. And if I don't simplify that, it can be marked wrong. So I need to look at those 3 positions to see if any number will divide evenly into those 3 terms. So my answer, today we're leaving everything in radical form. So we'd have negative 2 plus or minus the square root of 6 over 2. Now, there are some problems that do not have solutions. If you have simplified everything in the radicand and you end up with a negative number, there are no real roots. No real roots. So this is a negative number, which gets us into imaginary numbers, which is really something you'll run into when you get to calculus. If for Algebra 1, if we're looking at a negative number in the radicand, we're going to say there are no real roots. So you don't have to solve that. Once you simplify the radicand and have a negative number there, you can stop and say you have no real roots. All right, that'll get you guys started on using the quadratic formula. Have a great day. OUT spells.